Hello class, welcome to chapter 9 in Oracle. This is this chapter is going to be over joining data from multiple tables. And so really what this chapter is all about are something that we call joins. Um, there are several different types of joins. Some are more common than others, but joining data from multiple tables is really um, what makes relational databases such as Oracle so powerful. So you can take data that is related in multiple tables and join it together using different types of joins, um, and then that allows you to pull that data together. So, for example, as we're going to see in some of our examples from the book, let's say in our Just Lead Books database, you have a table called Books and a table called Publisher. The Publisher table has all of the publishers. The Books table has all of the books. Well, what if you want to see all of the books and who published them? You can join those tables together, join that information together, and then your query will return um, information from both tables where they match. So we're going to get into this. Some joins that we'll talk about aren't used quite as often I guess in the real world as other joins are, and I'll kind of point those out as we go along. So the objectives of this chapter, we're going to identify what a Cartesian join is. We're going to create an equality join using the where clause, create an equality join using the join keyword, create a non-equality join using the where clause, create a non-equality join using join and on. Then we'll also talk about self-joins using both where and join, and then we're going to distinguish what an inner join is and an outer join is, and then we're going to learn how to use outer joins. And then finally, we'll use set operators to combine the results of multiple queries. That's mainly using the union operator. So again, the purpose of joins are used to link tables and reconstruct data in a relational database. Joins can be created through conditions in a where clause or using a join keyword in the from clause. So this is a really important thing to point out here. Traditionally in Oracle, they use what are called traditional joins. So to relate the data between the two tables, they would utilize the where clause to join the two tables together. So the where clause, as we saw in chapter 8, um, we can restrict the data down using the where clause. And in the particular case of joins, we can use the where clause to uh, relate the two tables, relate two columns or two fields on each table. That's the traditional approach, and as we go through examples, you'll kind of see what I mean. The ANSI related, ANSI, that means ANSI. The ANSI method, or ANSI compliant method, I should say, is to actually use the join keyword. Um, I've seen both methods of doing joins used in the real world, but by far the ANSI method, I believe, is the most common. To me, it's the one that's easier to use, that's easier to understand. So in the homework that we'll be doing in this chapter, I'm going to ask that you guys only use ANSI joins, and don't worry about the traditional joins. We'll look at them so you guys can kind of see the two different ways, but I don't want you guys to get too confused on which method is better, or to confuse you too much. Joins can be a difficult thing for some people to get their head around initially. Once you get it and it clicks, you're not really going to have any problem with it. Now you can get into some very complicated joins in SQL, but the basics of it, I think you'll get a pretty good understanding of it after this chapter. But kind of pay close attention as we go through. If you have any questions, always feel free to email me and reach out. It's one of those things where I think if you practice it and really study it and see how it works, it'll click, and then you'll be good to go. Okay. So the first point we'll talk about here are these Cartesian joins. So you may have heard of a Cartesian product before. Cartesian joins is rarely something that you're going to be using in practice. It's something that can be used for statistical analysis or statistical procedures in SQL. For the most part, you're never going to use this, but it is important to know, I think, what they are. So a Cartesian product, Cartesian join, if you join two tables together using a cross join or a Cartesian join, you're going to be then listing, the results are going to have every single possible row combination within that table. So when you have very, very large tables, if you run a cross join against those tables, you are going to get an unbelievable amount of results because it's going to show you every single combination of rows. So the more rows you have and the more records you have, I'm sorry, the more columns or the more fields that you have, and the more records you have in each table, the more combinations you'll have and the more results you'll get. So usually it's a bad idea to use a Cartesian join or a cross join. I guess it could be useful in some cases, but for the most part, we never want to use these. They put a lot of strain on your database as well. So we can look at this briefly in our environment because the tables that we're using in the Just Lead Books database are very small, and we can quickly run an example. By the way, when you're using SQL Developer, make sure you're running the JLDB script for build script number 8. Run that in SQL Developer. I like to just copy it in there. Use this button, that's the run script button, to drop all the tables and recreate everything for this chapter. So just really quickly, let's run one of these cross joins or Cartesian joins. We're going to select title and name from books and publisher tables. And then we click the green arrow to run it. And as you can see, it fetches the first 50 rows, but as we scroll down here, we can see there's actually 70 results. So these are all of the different combinations. So you can see it lists every publisher along with every book title. So it's listing every combination of book title and publisher name within our database. Here's an example using a cross join as the keyword instead of using the without a condition on the query. But as you can see here, we're just selecting ISBN, title, location, and then a blank field that we're going to give an alias of count. And we're going to select that from books, and we're going to cross join warehouses and then order it by location and title. So that's going to give us every ISBN number, every title, and every location for where they're related in between books and warehouses. So again, it's going to give us every row combination in our results. Okay, so that's it for Cartesian joins. Let's move on to equality joins. Now, equality joins are by far the most common type of join and the type of join that you're going to be using most often in practice. You're linking rows through equivalent data that exists in both tables. There are several different ways that you can create equality joins, and we're going to look at each of them. But before we do that, let's just talk a little bit more about how tables are related, and how we can kind of, when we're going to think about setting up our join, how we're going to go about doing that. So if we go back and look at these two tables, books and publisher, I'll start out by looking at the books table. So if you look at this books table, you have the ISBN number of the book, the title of the book, the publish date, and then you have something called a publisher ID. So this publisher ID tells us who the publisher is of the book. Now all we have here is an ID number. We don't have the actual publisher name. So the idea in a relational database is that you don't need every piece of data on every table. You put only the data you need on each specific table, and then you join them. You can join them together or relate them together. So we don't need to list out the publisher name on the books table. We have a publisher table called publisher. From. And as you can see on the publisher table, the primary key on this table is the pub ID. 1, 2, 3, 4, 5, and it lists the publisher name and then some more information, the contact, the phone number, etc. So the field that we can relate these two tables by is the pub ID. We have a pub ID here, and we have a pub ID in publisher. So as you can see, pub ID 1 is printing is US. That's the name of that publisher. So when we look in the books database, in the books table, this record here that has a pub ID of 1, that's going to be that publisher. So if we were to join these two tables together on the pub ID field, so that's the field that can tie these two tables together. We can then also pull in other information from the publisher table by linking it using pub ID. So we can pull in the publisher name for each one of these books based on this pub ID. We could also pull in other information such as the contact or the phone number, etc., into a query using an equality join on the pub ID. Now, tables can have multiple fields that relate them together. Usually, most of the time, I would say it's only one field that links the two tables, but there could be multiple fields that link the tables, especially if you have a table that has a compound primary key where you have more than one field that creates a unique record in that table. When you do your join, you may end up having to join on multiple columns. We won't really get into that in this chapter, but in more advanced queries, that may be something that you have to look at. So again, as I was saying, there's multiple ways that you can do an equality join. The first one we're going to look at briefly is how to use a where clause. Now again, this is the traditional way to do a join, not something that's super commonly used. I definitely want you guys to use ANSI joins that we'll see here in a second. But just so you can see it, let's use this as an example. So we're going to select the title and the name from the books and publisher tables. Now, as you know, if we stopped right here and ran this query, it's a Cartesian product or a cross join. It's going to give us every row combination. So instead of doing that, we can filter this down using the where clause and join these two tables together on the pub ID. So using the where clause, we say where books.pubid equals publisher.pubid. So one thing to note here is that we're using the identifier, the table identifier. I think this is supposed to be books. There we go. we're using the table name as an identifier for the pub ID column. So we're saying where books.pubid equals publisher.pubid. If we didn't have these in here, Oracle's going to give us an error and say that, well, in this, I guess in this case, it's going to tell us that the table or view does not exist. Let me try that again. Let me put the books and publisher tables as the qualifier back in here. Let's go ahead and run this query. There's my problem. I have. Why didn't you guys tell me? Just kidding. We had a typo in the publisher name. Okay, that's more like it. There we go. Column ambiguously defined. So Oracle doesn't know which table you're referring to if you don't put the qualifying table name in there. So if we add books and publisher back in here, then we're going to get our join is going to work. So we have the title name of the book and the publisher because we joined it on the pub ID field in the where clause. One thing you can do that's going to make your life a lot easier is alias the tables as you put them in the from line on your query. So for example, if you alias that as books as B and publisher as P, you can also say as B and as P, either way. You can then reference much more quickly. You can call this B and this P, and then it's going to make it much easier than having to type out the full table name every time. Okay, so again, if you don't qualify the names of the columns, qualify the columns with a table name, such as books or publisher, you're going to get this column ambiguously defined error message when you run your query. So another point to make is that when you're using the where clause and using these traditional join methods, you can add other conditions into the query. So you can filter this. So for example, you can filter it where the publisher, the pub ID is 4. So if you want to only see the results where the p.pub ID is 4, and the pub ID is 4, you can filter it down that way too. So you can still have other conditions in your where clause besides the joining condition right here on pub ID. So you can also join more than 2 tables. In the traditional join, you just list the tables out separated by columns. So in this particular query, they're selecting from customers, orders, order items, and books. And then you can see in the where clause for each one of these joins, they're joining this customer number. Also, this is where aliases come in extremely handy because you have 4 different tables. So instead of having to type out every single one of these, they've aliased them. Customers table is C, orders table is O, order items is OI, and books is B. So they're joining customers, the customer number field on the customers table to the customer number field on the orders table. Then they're joining orders table to order items, and based on the order number, and then the order items to the books based on ISBN. So they're joining all four of these tables together on their common fields, or where they have foreign key relationships to those other tables. And then they're doing an order by. So there's three different join conditions when you're selecting from these four tables. So the point here again being, you can join multiple tables in your query, and many times in the real world that's usually what's going to happen, because many times the data you're trying to retrieve in your query is scattered out among multiple tables, and you have to have these joins with multiple tables in there in order to get all of the data that you need. Okay, so now let's skip over. So we've talked about traditional joins using the where clause. Now we're going to skip to the ANSI join, or what I really want you guys to use by using the join keyword. So again, as we go through the rest of this chapter, I'm sort of going to skip over the traditional join method. It is something that may be on quiz. When you do your homework, I don't want you to use the traditional joins. I want you to use the ANSI joins using the join keyword that I'm about to show you. So we'll focus in on this from this point forward, but just be aware of how the traditional joins do work in case you're asked a question about that. So the first, there's a few different types of methods that you can use when you're doing the join, using the ANSI join method as opposed to the traditional method. So you can use a keyword called a natural join. You can use a keyword called using, or you can just use the join keyword using the on clause. So let's go through all of those. So first, let's talk about a natural join. So in this query, we're going to select again the title, the pub ID, and name from publisher with a natural join on books. And one other thing I just thought of that I wanted to go back and show you here is if I try to select pub ID here, I'm going to get a column ambiguously defined. So if you try to select a column that has the column name exists in both tables, whether they're actually related or not, it's possible that they're not related, but because you may have in the books table, instead of title, you could have a column called name, for example. But if you try to select this, Oracle doesn't know which pub ID you're referring to again. So you have to either choose books or publisher as the pub ID you're going to select. Now, if you're going to select the column that you're joining on, it's usually not going to matter which table you pull it from, but because they should be the same. But that's just something else that I wanted to add in there. So anyway, back to the natural join. So you use the natural join keywords to join publisher to books. Now what this does is it will automatically join the publisher and the books tables together based on column names that are the same. So it's going to automatically join based on the pub ID field, pub ID column, which is the same in both tables. So if I do books and I do natural join on publisher, there is the join. Same results as before using the where clause, but this time we're just doing a natural join. So it automatically joins those tables. Now, the trick here is that you have to have the same column name. The column name has to be the same on both tables for this to work. If you don't have matching names and you need to join on two columns that have different names, the natural join isn't going to work and you're going to have to use something else. Um, and again, you don't have any qualifiers, so you don't have to qualify the column name. So if I added that B dot pub ID back in here, it's not necessary. You're not going to need a qualifier when you do a natural join because it's just automatically matching up the names of the column names on the tables anyway. Then you can also have a join using the join keyword and the using keyword. So the using clause, the using clause, I guess it's a clause, not a keyword, but the join keyword and the using clause allows you to create joins based on a column that has the same name and definition in both tables. So if you want to specify which column you want to join on, natural join is just going to join on every column where it has the same name, where the column names match. If you only want to restrict that down where you're only joining on a specific field, which is probably what you're going to do most of the time anyway, you use the using clause to specify that. So I'm not going to type this out in SQL Developer, but you can read here that we're going to select the title, the pub ID, and the name from publisher. Again, we're going to qualify again. So we've aliased publisher as P and books as B. And then in the select statement, we have to specify which tables we're going to be pulling the data from. And then we're going to say we're publisher join to books using, and then in parentheses you put the name of the column that you're going to be joining on. So in this case, it's pub ID, and that will get us the same results as we had before in this natural join. Finally, probably the most common way to do joins, and this is the way I would say most joins that you're ever going to do, I would say 75% of them are going to be written just like this. Because many times the column names aren't necessarily the same between tables, or there could be other reasons you need to do it this way. But most of the time, this is the way you're going to see joins written. Even if the column names are the same, a lot of times people just use the join on as opposed to using quite often anyway. So I'm going to go ahead and type this out. Let's do this so that way we let's see. So we're going to select, I like to start out by just saying select star from publisher to P join books B on P.id equals B.pubid. Then I go back here up here to my select statement and I say, okay, I want to select the title from books, so I do B.title. I want to select the pub ID from books, so I do B.pubid. And I want to select the name from publisher, so I do P.name. And then let's run this. And there we have it. Same 14 records. Again, we're just specifying, and again, this is publisher 2 because publisher 2, if we look in here, publisher 2 name is not pub ID, or the column name is not pub ID. It's just ID. And in the books table, as we know, the column name is still pub ID. So to join it with two column names that are different, we use this on clause to specify the column names that we're going to do the join on. So again, just to reiterate, we're selecting from these two tables, and we're telling it to join, we're selecting from publisher 2, and we're telling it to join on books where these two column names match. So where those two column names are equal, that's where we're going to join the data together. So if this one is 4 and this one is 4, give us this information. Okay? So give us the publisher name only where the pub ID and ID fields match. So where they're equal. So if they both equal 4, we're going to give you, I want you to give me the the publisher name for that book where they match on 4. So again, so you can see where the 4 is here, it's reading materials is the publisher name. Okay. So just to kind of recap here, if we're going to use join and then the using clause, we want to do that when we have tables that have one or more columns that are in common. If we want to use join and then the on clause, that's when the same named columns are not involved or a condition is needed to specify a relationship other than equivalency. Which basically means if you're using the join keyword, it frees the where clause for exclusive use in restricting rows. So, whoops, sorry about that. So when we do it this way, then we can come down here and say where p.pubid, p.id is 4. And we can restrict using the where clause that way. We don't have to muddy up our where clause trying to join, adding in the join for these two tables. We can use the where clause to say where it's 4 or p.name is reading materials Inc. and do it that way. Or you can say where it's 4 and the b.title equals the walkway to cook, and restrict it down that way. Okay, so next we're going to be talking about non-equality joins. So again, these were all equality joins where the column names, where we're wanting to say join these two tables together if the column names, the values in the columns are equal. These types of joins, non-equality, is where you're wanting to say, okay, they're not necessarily equal, and it's a non-equivalent condition. We could do it two ways: traditional join or the ANSI join method. But we're going to gloss over a little bit the where clause method and skip right over into using a join on as we did before. So I'm going to move this over here again. And the two tables we're going to be looking at here are the books table. So we know the books table. Now we've got the names of all the books. Keep forgetting my from clause tonight. So we know the books table. And then we're also going to be using the promotion table. The promotion table has the different gifts that you can get, and it's got a min retail and a max retail. So if the values fall in between here, I think that's when you get these different books. So if you spend between $0 and $12, you might get a book marker. If you spend between $12.01 and $25, you'll get a book label, etc. So for this non-equality join, we're going to be using the between operator to do our join. So let's give it a shot here. So again, I always like to do select all. You don't have to do it that way if you don't want to. That just makes more sense to me because I like to set my join up, and then with all my aliases and qualifiers and all that, and then I like to go back and say, okay, now that I've set up the relationships in this join, then I'm going to go back to the select line and actually tell you what data I want to see come back. So if we say from books B and then join promotion P on B.retail is between P.min retail and P.max retail. Then I'm going to go back to my select. I'm going to say, give me the title and give me the gift that you'd get. You can select all of this and then click run. It would help if I spelled that correctly. Let's try that again. And there we go. So looking at the title, Big Bear and Little Dove, we can see in our results that we're going to be getting a gift of a bookmarker. If we get Revenge of Mickey, we're going to be getting a gift of book labels. So again, what we're doing here is we're looking at the books table and we're looking at the retail column. So that's how much the book costs. So for example, if Revenge of Mickey, the retail is $22, we're saying, okay, if the retail is between the promotion table, the min retail and the max retail values in the promotion table, join those columns together. So give me the gift from the promotions table where retail is between these two values. So again, if Revenge of Mickey is $22, sorry, and we're looking at the promotion table, and that should be a book label, right? Because 22 is between $12.01 and $25. So when we run this query again, we should see that, yeah, Revenge of Mickey is a book label. If you want to look at another book, let's say Painless Child Rearing, that's $89.95. That should be anything over $56.01 up through $999 is free shipping. So I should be getting free shipping on the Painless Child Rearing title, that's what it shows. So that's an example of how we can do a non-equality join using the join method, using join and on keywords. Okay, so the next section or next type of join we're going to talk about are self-joins. Self-joins are actually really cool. I could remember when, a long time ago, when I first kind of discovered self-joins and was learning SQL, and when I realized what kind of the power and what you can do with the self-join, I thought, oh, that's really cool. For a little bit, it takes some time to wrap your head around it, because you're used to joining data and thinking about it where the data is on two different tables and you're joining two different tables together. And a self-join is when you actually join the table to itself. And the reason you'd want to join a table to itself is if you may have data on a table that you want to relate to each other. A good example, and one that I think is in your homework, hint, is if you have an employees table, well, you may have a list of employees in the table, but you also may have a list of who their managers are. And then when the list of employees, you may have, okay, employees John Smith, you have their first name in one column and their last name in another column. And then all you may have for their manager is the manager's employee ID. So I'm sorry, then and you also may have in that column or in that table an employee ID for each employee. So you have an employee ID, a first name, a last name, and then a manager ID for that employee. So what if you wanted to give some results where you saw the employee ID, the person's name, and then the manager's name? Now you don't have the manager's name anywhere else in this database except on the same table as the rest of the employees because the managers are employees too. So if you join that employees table to itself, you can then list both the employee's name and their manager's name in the same query by using data that's on the same table. So it's going to require you to use a table alias because you can't select from employees twice, so you're going to have to call them two different things. So you may call it employees table A and employees table B. It's really the same table, but you've aliased them differently. And then you're also going to have to use a column qualifier. So whenever you're doing in the select line, you're going to have to say use the employee ID from alias A and the employee num from alias B. Let's look at an example and hopefully this will make a little bit more sense. So here's an example using the customer table of our books database. So you can see Leela Smith, her customer number is 1003. And if you follow this line all the way around, you can see that under the referred column that this person down here, Tammy Gianna, was referred by customer number 1003. So she was referred on this customer was referred by Leela Smith. Similarly, Misha Cruz referred Nicholas Nguyen. Okay? So we can now then do a self-join on this customers table and see who referred, get the first and last name of the person who referred these people. So let's take a look. So this is the where clause example. Again, I'm going to skip over that. You can always go back and review this in your book. All these examples are in your book. I'm going to go over to the join on method. So let's kind of walk through this. We're going to select, again, I'm going to skip over the select statement, the column name, and go right to the tables first. So we're going to select from customers C, so we're giving it an alias of C, and then we're going to join customers again, the same table, but this time we're going to call it R. So we're going to join the table to itself using a self join, and then we're going to join it on C.referred equals customer number. So if you go back up here, we're joining this referred column to the customer number. So we're saying where referred matches the customer number, join the fields. What that's going to show us, if we look in our select statement, we're going to select the first name and last name from the R alias. We're going to select, but then we're going to select the last name from the C alias, and we're going to call it referred. So that's going to tell us we can get Leela Smith and see all the people she referred. So Leela Smith referred Smith, Perez, and Gianna. And Misha Cruz referred Nguyen. So if you look at this, Gianna, Perez, these are people that Leela Smith has referred, as well as herself, apparently. So again, we've joined the same tables, joined it to itself, given it a different alias, and we're joining it on between the referred column and the customer number column. But then when we select our data, we're going to select from the different aliases. So this is going to allow us to get other data from that same table. Hopefully that makes sense. Um, Again, email me if you have any questions or don't quite understand how that's working. And I think if you play around with this and run this query, and also when you do your homework, and I believe you're going to have one using managers and employees, play around with it. It should make sense, once you start to run those queries. Okay, next thing we're going to talk about are outer joins. So all the joins we've been talking about up to this point are really known as inner joins. And in fact, whenever you um, join these tables, um, instead of using join, a lot of times what you'll see is inner join. Um, I actually do personally do that every time. I just specify it as an inner join. The reason why I do that is because you also may have outer joins. Outer joins are usually left joins or right joins, although you can also have full, or you can use the word outer join itself as the keyword. I always specify inner join, but the inner, whenever you just use join, the inner is kind of implied. And what you're saying there is you're wanting to join on tables where the values are present in both tables. So on the books table and the promotion table, you're wanting to join where they exist on both tables. But in practice, that doesn't always happen. Sometimes you may want to include rows that do not have a match in the other table. So if you were joining on two tables using an inner join, or just the join keyword, let's say there were 50,000 records, and you join on a particular field where there were only 10 matches, you're only going to get 10 records back. So I think in our books table, yeah, see, we don't really have a great example in just lead books because we have 14 records, and our join brings back 14 records because there are 14 matches. But if there was a book title, let's say, that um, had, maybe we can try this. I hadn't really planned to do this, but let's try it real quick. Let's say this promotion goes down to 0. Let's see if this will work. If I make for this ISBN number, let's say if I update books set retail equal to -1, where the ISBN equals that. So I'm going to update this and commit it. And if I look at my books, I have a retail cost of -1, which obviously would never happen for this body build in 10 minutes a day. Now if I run this query again, I did get 14 last time, but now I only got 13, and you can see that I don't have that bodybuilding book listed in this table anymore. And the reason is because there was no match. So in this promotions table, I'm trying to match where the retail price is in between these columns. Well, -1 is outside of this. So there's no match in the promotions table any longer for this bodybuilding in 10 minutes a day because the retail is -1. So we only get 13 records now instead of 14. So the inner join, when you're using a regular join, that's going to restrict your data down. It's going to filter it down only where there's a match in both tables. So that's where the outer joins come in. An outer join is going to allow you to include rows that do not have a match in the other table. So hopefully I can show you here in just a sec. If we do a left join, now we have 14 records again, and we see body build in 10 minutes a day. The gift is null because there is no match. So let's talk about this a little bit more. So the where clause again, just gloss over this, but this is where I think the traditional method gets a little bit messy, because you have to use this plus sign operator um, on the table that you want to do the outer join on. So for example, on this one, if you're going to do the outer join using this where clause method, in the where clause you have to put a plus sign out by the table that, or the column that you're going to be doing the join on. So this is kind of like a right join, because it's on the right table. You could put the plus sign over here. I guess it would be a left join on the left table. It gets really messy when you start doing this. If you're using the join method or the ANSI method, you can just say left outer join, or you can just say left join. You don't have to use the outer keyword if you don't want to. But you're going to join customers with a left join on orders using customer number. So all I'm saying here in our query in our example that we used, is give me all of the records for the table on the left, which if you think about it like this and you're reading this left to right, this is how I always keep it straight. Books is on the left, promotions on the right. So we're going to say give me all of the book titles, and then any matches between the two tables, join in the promotion table P. Okay, so if there's a match, give me every book title, but only give me the gift where there's a match. So there was no match for the body build book, and that's why it was set to null. So the outer joins are a good way to see lots of records, and where you can see all the records in one table, but then you can also only see the matches from another table. If I did a right join here instead of a left join, we're back down to 13, because again the right table is over here as promotion. So this is saying give me all the promotion records, and only the books records where they match, and they only match on 13. Okay. Oops, so left join. That's where we're at. And you can do multiple joins. You can have inner joins, left joins combined in the same query. But most of the time, if you're using a left join, you're probably going to have to use a left join on any other joins you use in the query as well, because you're going to want to see all the records on that left table. Okay. Right here, if multiple join conditions are used, the outer join condition may be required and all of the join conditions to retain non-matching rows. So if you want to see all the non-matching rows, you're probably going to have to use the left join or the outer join on every join. So this is also kind of cool, because when you do this, if you want to quickly see the non-matches, then you can use a where clause and say where p.gift is null. Oop. And that way I can quickly see, okay, give me where there's no match. Let me know, this query is going to tell me, okay, give me where the books that don't have a match, that don't have a gift. I can filter things down using null when I start to use the left and use the outer joins, which is really helpful and really useful a lot of times. This is talking about a previous version of Oracle, so we don't really care about. Okay, last thing, set operators. They're used to combine the results of two or more queries, or two or more select statements. So these are, again, since we're talking about joining data from multiple tables, these aren't really joins. These are operators that you can use to combine data from multiple queries. So the main one you're probably going to use, and the one that you're ever going to use, that honestly, personally, I'm just going to tell you, I've never seen intersect and minus actually used in the real world. I'm sure it is all the time. Personally, I've never seen it. Union and union all, though, that does happen from time to time. So a union will return the results of both queries and remove the duplicates. Union all returns the results of both queries but includes the duplicates. So as an example, we're selecting the author ID from books, where the category, we're going to do a join on the ISBN number, where the category is family life, and then we're going to union the same query, so the same we're selecting the same field, doing the same join, but this time we're going to say where the category is children. So that's going to give us the results for both family life and for children by using the union. But since we're using union, it's going to remove any duplicates. So if there were multiple B100s, so if there was a book that had both that was in the category family life and in the category children, it's only going to give us that one time. If we use union all, we're going to see we could see duplicates here. So B100 may be the author ID for one of these books if it appears in both categories. It'll be listed multiple times. So that's union and union all. That can definitely come in handy from time to time if you're wanting to see data from two different queries. The thing you have to remember when you do a union is that the select statement has to be the same. So you have to select the same number of records that have the same name. So even if you have to alias the records, you can do that. They just have to be the same for every query that you're unioning. Truth be told, the joins between the two queries that you're doing a union on don't have to be the same. What does have to be the same is the select line. As long as you have the same number of columns and they have the same names, you're going to be able to union the two together, even if the where clauses and the joins are different, if that makes sense. Okay, so that's union. Intersect returns only the rows included in the results of both queries. So you can return only the rows included in the results of both queries. So you're just going to return the rows that are included in these two queries, and then the minus subtracts the second query's results if they're also returned in the first query's results. So again, just a way to remove the duplicates. There's an example of minus. Okay, so just a quick recap. Joins, we're going to take data that's stored in multiple tables regarding a single entity that can be linked together through the use of joins. So that's the way we can relate our data, relate our tables, and query data from multiple tables and show it in the results. Cartesian join between two tables, or also known as a cross join, is going to result in all the different combinations of the rows, n times n. An equality join is created when the data joining the records from two different tables are an exact match. So again, equality join means that they match. A non-equality join establishes a relationship upon anything other than an equal condition. So that's where we used our between statement, between operator, to join the two tables together. So they're not equal, but we can establish a different type of relationship. Self-join is where we're going to join the same table to itself. And then inner joins can be equality, non-equality, or self-joins. An outer join is created when the records need to be included in the results without having a corresponding record in the join table. So if you want to see all the records from one table and only the records where there's a match from the other table, you use an outer join. And then we can use set operators like union, union all, intersect, and minus to combine the results of multiple queries. Okay, so I know that was a lot. Joins, again, can be kind of a complicated beast. What I would encourage you to do is to look at each table. If you're trying to figure out how to join a table, join two tables, look at the data that's in each table and look to see how it relates, how you can join it together. Then start by using a natural join. or using the using clause, and then work your way up to using maybe the on clause as well. And once you start to make that connection and do some basic joins, like from the examples in your book, then you can start to add a little bit more. So maybe you want to do multiple joins on tables, or maybe you want to try doing a left join or some other type of outer join. That gets a little bit more complicated, but once you have the foundation of doing a basic equality inner join, that's the kind of, I think, the building block to where you can then start to do other joins and they make a lot more sense. Again, as always, send me an email, reach out to me, get in touch. We can through talk through any issues that you may be having. Okay, that's it. Thanks, guys.